So when you see the words implicit differentiation, what it's saying is that when you try to evaluate a derivative of y with respect to x, or whatever other variables we put in there, you sometimes can't find what y is with respect to x. We don't know what y is as a function of x. Like this equation, we can't really get a closed form solution of y. We can't just get y equals blah and then differentiate that. If we could, then we wouldn't need implicit differentiation. So what we're doing is we're trying to find a derivative with respect to x of this whole thing. But when we get to the derivative of some term involving y, then we need to write it as dy dx. Okay. And then we can eventually algebraically solve for all the dy dx's. This is like the variable we're trying to solve for. Okay, so let's go through the process. It usually makes sense when we see a question, right? We can just write this, d dx. We're taking the derivative of everything with respect to x. So that means x is our variable of differentiation. That means when we get to y, we need to use implicit differentiation. Okay, so derivative here. There's an outermost function, and then there's an innermost function, so we need the chain rule. So the derivative of the outermost function, the 3 would come down, the innermost function stays the same, just like the chain rule has taught us, and then the power gets reduced by 1. But then we need to chain it by multiplying onto the derivative of the innermost function. So the derivative of the inside here, negative 8x minus 2y. That derivative is negative 8 minus 2 dy dx. The y doesn't disappear. There's no power rule happening right now with y. I guess you could think of the outermost function as 1, but it's not. We're differentiating with respect to x, so we don't know what this is as a function of x, so we just have to write it as dy dx. It's like we're saying, hey, this is where we would put the derivative of y with respect to x if we knew what that derivative was. So everywhere where you see a y, you're going to have a dy dx come out. Oh, and this should look like this because we're differentiating both sides. So the derivative of this is nothing tricky, negative 2x using the power rule. The derivative here is negative 20y times dy dx. Because the 2 comes down and multiplies, and then the power gets reduced by 1, so that's why I have y to the first. But then a derivative of the innermost function, the derivative of y, is dy dx. So by the chain rule, we have to write dy dx on the outside there. Okay, and so the rest of this is just trying to get dy dx by itself. So what I'm going to do is I'm going to collect my dy dx terms on one side of the equation. So I'm going to add, what's easiest? Yeah, this is probably easiest. I'm going to add 20y dy dx to both sides. Oops, I forgot to add it. There we go. And so since I'm trying to get dy dx by itself, I need to get rid of this term. I'm just trying to make everything as simple as possible just so I can have a dy dx on both sides. I guess I don't have a choice. I have to distribute here. So I'm going to take this negative 8, and it's actually like this is one big term. This number multiplies to the negative 8, and it also multiplies to this term here. So when we do that, negative 8 times 3 makes negative 24. And then when we distribute this term to the second term inside the parentheses, the negative 2 times 3 makes negative 6. And it's still dy dx. And we're still trying to get dy dx by itself, so this term needs to go. That doesn't have anything to do with dy dx, so let's add that to both sides. So that gets rid of it on the left side, so we're just left with all the dy dx terms. So I took this and I added it to both sides to make it cancel out here. So it gets added over here. I just put it in front because it has a positive coefficient, so I had it lead in the way there. So this term has a dy dx, this term has a dy dx, so now we can factor out dy dx from both of them. So here we're left with negative 6, negative 8x minus 2y squared plus 20y equals all this mumbo jumbo on the right. And then we're trying to get dy dx by itself, so the last step is to divide this from both sides. So we're going to get dy dx equals all this stuff divided by this stuff. It's 24 negative 8x minus 2y squared minus 2x over negative 6 negative 8x minus 2y squared plus 20y. So the derivative of y depends on y, and that happens a lot with implicit differentiation. Simplifying, what can we do? We could factor out a 2 from the numerator and the denominator. So that'd be 12 negative 8x minus 2y squared minus x. And the 2's are just going to cancel if you factor it out from the top and the bottom. So this is negative 3 negative 8x minus 2y squared plus 10y. So this one's a bit easier. If you got lost in the algebra in the last one, hopefully this one will help. We need to implicitly derive, we need to find dy dx basically. So let's take the derivative with respect to x of everything here. And this is a fourth root. That means it's x to the 1/4 power. So with the product rule, that means 1/4 comes down, and then it gets reduced by 1. So it makes negative 3/4 for leftover. And then here, the derivative of 2y to the 2/3, the 2/3 comes down and multiplies. And then it gets reduced by 1. So 2/3 minus 1 makes negative 1/3. And then this equals 0. Oh, whoops, whoa, I missed the big part, right? This is the whole point. Now dy dx has to be left over. Because we use the chain rule when we differentiated the outermost function, the 2/3. The 2/3 came down, got reduced by 1. But then there's still something left here. The derivative of y with respect to x is something we don't explicitly know. So we write it as dy dx. That's the implicit differentiation part. And I almost forgot it. And the derivative with respect to x of 75 is 0 because there is no rate of change of 75, just constant. And now it's just algebra to get dy dx by itself. We'll subtract this term from both sides. So that leaves 4/3 y to the negative 1/3 dy dx. And that equals negative 3/4 x to the negative 3/4 power. Still trying to get dy dx from both by itself, so I'm going to divide this from both sides. So that's dy dx equals, now you'd have to flip and multiply. Yeah, it's too bad. It looked like they were going to cancel out, but it's not. It's going to be negative 9/16 when you flip and multiply this fraction. And then we're dividing by y to the negative 1/3 power. So you can make that a positive 1/3 power by moving it upstairs. And it's x to the negative 3/4, so we can make that positive by putting it downstairs. So let me go check and see if Newton accepts this. We could simplify. We could rewrite. That's a cube root of y, and we could rewrite that x too. I'll check and see if it accepts both these. But that's cube root of y in the top. That's what a 1/3 power means. And this is x to the 3/4, so I'm going to put an x on bottom and then a 4th root of x on top. Because a 1/4 power subtracted by 1 makes negative 3/4. And you can make the negative 3/4 positive by putting it downstairs. So this is the same thing. And by the way, that 3 is on the root.